All right, let's go ahead and get started. By the way, I've been asked by a couple of you this week. Yes, that is my dog at the end of those videos. That's our border collie, so mystery solved. All right, so today we're here to talk about Exchange 2013, high availability and site resilience. Just out of curiosity, how many of you were here last year at this session? All right, not too many. How many of you have deployed 2013 already? All right, a few of you. All right. So last year, that was actually the debut of this content, the public debut of this content. Prior to TechEd New Zealand last year, we had only talked about these kinds of things internally at our own internal events at Microsoft. But since we covered all this stuff last year, and since there's many, many recordings you can go and watch of it, I decided instead to have a whole new agenda and cover all new and different things. So I think between the two sessions, I think that should give you a pretty good handle on where we are with HA and site resilience, including some storage changes that we made, and how to configure and control things. So the agenda today, we're going to talk about the database availability group architecture. For some of you, this may be a bit of a refresher, but we have actually changed the architecture slightly in Cumulative Update 2, so we're going to go over those changes as well. We're going to dig into all the components that comprise a DAG and how we use them. And then from there, we're going to talk about things like your witness server placement, what Windows Server 2012 dynamic quorum means, and DAG member maintenance as well. All right, so let's start with the DAG architecture. We're going to go through each of the pieces, starting with the primary core component in Exchange 2013, which is called the Microsoft Exchange Replication Service. MS Exchange REPL is the short name. MS Exchange REPL.exe is the executable process. Now, inside this one service, this one process, are a number of components that are there doing a variety of functions to keep the DAG operational, to look up information, to report copy status and overall health status of your databases, and so forth. So for instance, you can see that there's 16 different components in there. I'm not going to go through each and every one, but I do want to talk about some of the more important ones. Obviously, there's an Active Directory lookup component. That is there so that when the client access server does a lookup to find out where the user's mailbox is located, that component can respond to that Active Manager client by looking up Active Directory, finding out where it is, and passing that to it. We've also got the copy status lookup. This is where we're looking inside the cluster database on a DAG member and inside the Windows registry on a standalone server to find out what the status is of your databases. And it's interesting to note that the replication service is a critical component, not just for DAG members, but it's actually required for all mailbox servers. And that was true in Exchange 2010 as well. And that is because inside the replication service is another component called Active Manager. And it's Active Manager that determines whether or not a database can be mounted by reaching internally what we call auto-mount consensus. And so to reach auto-mount consensus, we need to have quorum. The databases need to have permission to mount. They can't be blocked by an administrator, and so forth. So the information store still does the actual mounting, but now it will only do so if Active Manager tells it to do so. So that's why on your standalone mailbox service, the replication service is also required, even though you're not doing log shipping and replay. Some other things, the replay core manager, that's obviously there to handle the replication pipeline and the replay pipeline. So that will do things like track the last log received by the passive and transmit that information through a raw TCP socket that we maintain between DAG members. And it will go ahead and pass that information to the active copy to let the active copy know where it is in terms of log shipping. And if the active copy finds that the passive copy is up to date, we will actually slip into a different kind of replication called block mode, where instead of shipping closed log files, we will actually ship ESC buffers between the two systems as well. If we fall behind, we'll go back into file mode and end up shipping logs. But there's a persistent communication stream that we maintain between all of the DAG members, particularly between the passive copies and the active copies to track all of this information. There's the seed and the auto reseed manager. As their names imply, they're there to either provide an administrative interface and initiate these streaming backup APIs to do an internal seeding operation. Or if you're leveraging a new feature in Exchange 2013 called auto reseed, where we have the ability to grab a spare disk and automatically reseed it with the database copies that were on that failed disk, now we have a component inside the replication service to do that as well. There's the disk reclaimer manager. That works with auto reseed. That's the component that scans for the spare disks, makes sure that they're available, and then maps it into a mount point structure that auto reseed uses. There is the VSS writer. If you are doing a VSS-based backup against an Exchange 2013 server, it will be the replication service VSS writer that will interface with your VSS backup application and actually do the backup for you. It will also be that component that is responsible for writing the backup information into the database headers of the copy that you're backing up. And of course, once those physical changes are made, they'll get replicated through the system. And of course, there's Active Manager. We talked about that. There's the Failure Item Manager. The Failure Item Manager is there to write to the Crimson Channel event log so that if there's some sort of a problem in the DAG, the other components, including managed availability components, can subscribe to those events and find out about issues that need attention right away. There's also this TPR API manager. TPR stands for third-party replication. You do have the ability, as you did in 2010, to replace the built-in continuous replication with a third-party product that uses our third-party replication API. There's actually only one solution out there, one third party that is written against this API. I don't know of any customers who've actually implemented that. Most customers seem more than satisfied with the built-in replication that we have. But we still do support the third-party replication API if you're interested in that. The others, the health state tracker, the server locator, again, those are just to query the different repositories where we store information and to report that information back either to other DAG members who may be querying it or to an administrative interface in case the administrator is querying through the Exchange Admin Center or through PowerShell as well. Now, in CU2, we introduced a new service called the DAG Management Service. And there were a couple reasons that we did this, which I'll talk about in a bit. But the DAG Management Service is another unmanaged service. So it's MS Exchange DAG mgmt.exe, a nice unmanaged name, short name for you. And that's also there. That is also running on all of your mailbox servers as well. And that is there to basically take over some of the functionality from the replication service so that the replication service could be a little bit leaner in terms of its functionality. Again, going back, you saw that there's 16 major functions that the replication service is doing. So what we've done is we've moved 4 components over into this new service, but actually only one of them is doing work, and that would be the monitoring component. So the other components are there inside, but it was just literally a copy and paste of the code into a new process. So they're not doing anything right now. They're effectively neutered. The only process, or the only component that's active inside the DAG management service is the monitoring component. And because it's effectively forklift over from the replication service to the DAG management service, it actually will report things in the event log as if it were the replication service. So whatever the DAG management service does, it's actually behaving and sort of pretending to be the replication service for now. Eventually, that may change, but for right now, this is where we're at with CU2. So anytime that the DAG management service needs to write an event, it's going to write those events exactly in the same place where the replication service wrote them. And it's also going to use an event source of MS Exchange REPL as well. Again, we didn't change the source name, so we're still logging everything under that one name. So we created this separate service primarily for 2 reasons. Again, so the replication service would not become so bloated and have all this functionality to do, but also so that we would have more granular control over the functions that lived inside the replication service. So for instance, managed availability, after we start splitting more and more functionality out, managed availability has the ability to target termination of lower level functions without really dramatically impacting other DAG-related functions like replication and replay. Eventually, we do hope to move some of the other functional components out of the replication service and into the management service. Things like auto-reseed, things like the disk reclaimer, the dynamic replay lag replay playdown capabilities, which is the system's ability to bring a lag copy up to date in response to things like loss of disk space or constraint on the number of available copies that are available, or if the lag copy needs to be page patched because of some corruption in that copy as well. And then there's also some future work that will eventually make its way into this DAG management service as well. And you can kind of get a little glimpse into the future and see what that functionality is. Because if you take an Exchange 2013 DAG today and you run get database availability group, you're going to see a whole lot of properties that start with the term autodag. It's going to be autodag something. And so those properties are plumbed there for future use. So just by running get DAG, you can actually anticipate some of the functionality that will be coming later on as we move more and more functionality into this management service. Now, of course, every DAG is built on top of a Windows failover cluster. And we've been using the cluster service for many versions of Exchange, although our implementation of how we use it changed dramatically in Exchange 2010, and we've continued that change in Exchange 2013. The most significant difference is that Exchange is not really a cluster-aware application anymore. The cluster has no idea that we're there. There are no Exchange resources that are managed by the cluster. We're pretty much just a consumer of clustering technologies at this point. And you can see the four technologies that we use. Obviously, we use the cluster quorum model, and that feeds, as I mentioned earlier, directly into auto-mount consensus. We won't mount databases without quorum. The number one rule with a DAG is if you don't have quorum, you don't have an operating DAG. We also use it for membership and node management. This is how we group servers together, but it's also how we determine whether or not servers are up or down. We use the networking features of the cluster. Whenever you install, or whenever, rather, you create a DAG, we're installing the Windows failover clustering technologies. Clustering interrogates the network cards that you have in the system and passes that information on to Exchange, which turns each unique network card on a unique subnet into a corresponding DAG network. And so that's how we learn about the networks as well. And then there's the cluster registry, where we store a tremendous amount of operational data as the DAG is actually running. We store the data inside the cluster registry because the cluster registry, anytime you write to that, it's instantly replicated to all the other DAG members. So that's why we choose that instead of something like Active Directory, where we would be completely bound by AD replication latency. So by storing stuff inside the cluster database, or what we sometimes call the cluster registry, that gets that information around to all the DAG members very, very quickly. Now, as I mentioned, quorum is required in order to mount databases. It's just something that we use as a protection mechanism to prevent split brain at the cluster level. There is a separate functionality that we have called Data Center Activation Coordination Mode, which is there to protect you from split brain at the application level when you're doing a data center switchback. So after you've switched over your data center and you're switching back, we've got a second level of protection inside the application against split brain at the database level. Now, what's interesting is that quorum is based on votes, not membership. And that's because voting can be rigged. You can actually take quorum votes away from DAG members. But the thing about Exchange is Exchange takes a very simplified approach to quorum. Exchange actually uses membership count, not votes, which means if you do go ahead and manipulate votes, more precisely, if you take votes away from DAG members, Exchange won't recognize that. And so the quorum decisions that it makes in terms of what quorum model to use will be wrong. If you manipulate votes, what that means is you'll end up having to manually manage the quorum to account for that. So keep that in mind. The cluster and Exchange have diverged a little in terms of how they determine quorum now. Now, I mentioned the cluster registry, and I'll show you some examples in a bit. But the cluster registry is where we store all of the information related to database health, database status, whether or not a database is admin blocked from mounting, or whether or not the database has been dismounted by an admin, because we always honor the administrator's intention. And if the database has been dismounted by an admin, we won't go ahead and mount it as a result of that. And we also use that information as part of what we call our best copy and server selection. That's another thing that's changed. In Exchange 2010, we just had best copy selection because we were largely looking at just database and copy status health. In 2013, we need to look at much more than that. And the reason for that is because we need to make sure the protocols are healthy as well. We didn't have to do that in Exchange 2010 because things were largely separated from one another. But in 2013, all access and all of the session and everything related to a user's mailbox actually happens on the mailbox server that hosts the active copy of their mailbox. And so we can't just fail over to a place where we have a healthy database. We also have to make sure that the protocols on that server are healthy as well. So here's an example of what it looks like. You can see up here, it does look a little bit cryptic, but you can actually pretty easily interpret some of these entries here. So for instance, we can see the name of the active server, it's EX2. We can see the name of the server on which it was last mounted, EX2. We can see, the last time it was mounted, the current mount status, whether or not the admin dismounted it, and whether or not automatic mounting is allowed. In other words, is this database blocked from activation? So most of the things that you'll see in these registry entries are fairly self-explanatory, and you shouldn't have too much difficulty interpreting what you see in the registry. There are a variety of them. Each one of these is defined in the slide, so I'm not going to go through them in depth. But you can see now the kind of information that we have in the cluster registry and in the cluster database. And this is the same information we would store on a standalone server, except it's in a different place of the registry because there is no cluster hive on a standalone server. One of the other things that we store is the logging information. So what is the last log that this database copy received? We need to know that so that when the active copy starts sending more data, it knows what log to continue sending. And so that is all tracked inside there as well. We don't look in the file system. We don't consider a log to be successfully copied until it's both in the file system and written and updated in the registry as well. Once that registry update happens, then we consider that log shipped, and the active copy knows then the next log file to send after that. So you can see, for example, we've got a couple different databases in here, and you can see the GUID, which is the actual GUID for the database itself. And then there's a number here that it shows in decimal. So what you would do is you would whip out calculator, change it to scientific mode, or actually programmer mode now, punch in the decimal number, convert that to hex, and then you can go into the file system and correlate that with a log file, which are written in hex. Now, the Crimson Channel. I've talked about this a few times this week, but I wanted to go into a little bit more depth. This is an area inside the Windows event log that was created by Windows so that applications have a place to not just write events, but also to subscribe to those events as well. And in fact, in Exchange 2013, we used the Crimson Channel as a communication path between various components. So a great example would be Active Manager and the Extensible Storage Engine. So if the Extensible Storage Engine, ESE, if that has a problem, say for instance, writing to or reading from a database, it will log that in the Crimson Channel. Active Manager will see that event right away, and it will initiate recovery action as a result of that. So this is how these components interoperate. And in fact, the Crimson Channel is a necessary and required component for normal DAG operations. If we cannot read to or write from the Crimson Channel within a 30-second period, Exchange will self-recover from that by forcibly rebooting the server, or bug checking the server, as we sometimes say. And again, we do that simply because without that eventing path, we can't communicate between our components. Now, there's a bunch of channels that we have in Exchange 2013. Only some of them are really going to be interesting and relevant for you. Many of them are actually there to provide diagnostic and higher level information for the application developers. So what that means is, unless you have our symbols, which none of you do, you won't really be able to interpret those events. They'll just look like gibberish to you. But of course, they're in your event log. You can go and read them all and try to figure them out. But it's really the ones that are in the operational event logs and the troubleshooting event logs that will provide you with human-readable information. And then, of course, there's the managed availability areas of the Crimson Channel, which provide you with a wealth of human-readable information. One thing that I'll say, though, about those managed availability events, when you're looking at them in the event log, you don't want to look at them in the default view. You'll need to change the view to the XML view. It's just a radio button that you choose. But it's the XML view where we actually display all of the properties of the managed availability probes, monitors, and responders. Again, you won't see that in the default view. You just need to change to XML, and then you'll see the whole long list of stuff. So here's just a screenshot of what the Crimson Channel looks like. You can see it's here in the event log. It's under Applications and Services log, then Microsoft, then Exchange, and then here's the ones that would be germane to an Exchange 2013 installation. And again, the one that's going to be most interesting to you are the managed availability logs, the troubleshooters if you're running those, and then under high availability, there's an operational log that has some pretty good information in it as well. Otherwise, most of the rest of the stuff, as I mentioned, is either for consumption by Exchange itself or by our developers as they're doing some diagnostic work. All right, let's talk about witness server placement. How many of you feel like you're fairly confident in your understanding of what the witness server does and how it works within a DAG? Okay, maybe the better question is, how many feel like you're just completely confused by what the witness server does and how it's used and so forth? Okay, I see 2 brave people willing to admit that. Okay, so let me briefly explain the way we use a witness server, because it's actually a functional component of Windows Cluster, but what is, I think, really interesting about the file share witness, it was actually invented for and by the Exchange team. So it wasn't the clustering team that came up with this. This was the Exchange team that came up with this because prior to having the witness, we recognized that we didn't have a really good high availability story without having some external server that could act as either a tiebreaker in the case where you had an even number of DAG members, or something that could keep the DAG running if you lost half your DAG as well. So we actually came up with initially an HTTP-based witness server where we would make HTTP calls. That never got shipped, and the reason that never got shipped is because it just didn't scale the way we needed to. There was a bit of a delay with some of those HTTP requests that actually prevented us from being able to use that server as a viable witness server. So we moved to just a straight file share on a server somewhere. So the witness server is basically any server, Windows Server 2003 or later, that is external to the DAG, that is there, again, to provide a tie-breaking vote or an extra vote in the case the witness is needed to maintain quorum. That's really all it's used for. It's a very lightly used file share. It can go on pretty much any server in your organization that is not a member of the DAG for which that witness server is a witness. So the witness server can be a member of a DAG, just not the one it's a witness for. So say, for instance, you're in a site resilience configuration and you've created 2 DAGs that both stretch both sites. So if you lose the WAN, each side stays up with its active copies. In those cases, we would recommend that the DAG members be witnesses for each other as well. And that will save you some servers, and that will also give you a clean and simple configuration. But with Exchange 2013, we've also introduced a bunch of configuration options that are new and different, things that we couldn't do in Exchange 2010. So again, let's see. Let's make sure I covered everything here. So yeah, the witness server is not a member of the DAG, doesn't contain the quorum. It's got a file share on it, and the file share has 2 text files. One text file is there as a heartbeat ping from the cluster. It's called is alive. So that's the cluster periodically verifying that it can write to this file share. And then the other one is the text file that has the cluster Paxos information in it. Now, we use the Paxos algorithm in the cluster to figure out if we can maintain quorum or not. And it's really nothing more complicated than almost a date and time stamp that gets incremented as votes drop and as quorum is recalculated. So that's all that we use the witness server for. And in fact, except for the isAlive heartbeating that the cluster is doing, the witness server itself does not actually get used unless and until it's needed to maintain quorum. So if you've got plenty of servers available to maintain quorum, we're not using the witness server at all. It's just the cluster heartbeating it behind the scenes. Now, the guidance, excuse me. The guidance has changed a little bit. In Exchange 2010, we had very simple guidance, and that was to place the witness server in the data center where you wanted the majority of votes to exist. Very, very simple guidance. If your DAG was extended into a single location, that really became irrelevant. The witness server was typically located there as well. But if your DAG was extended to multiple locations, we wanted you to always put the witness server in one of those locations where you had the majority of your votes. In 2013, because of the architectural changes, because of the namespace simplifications that we've offered, and because of the new configuration options, the guidance is not that straightforward. You've got more options than what you had previously. And that's actually a good thing, because now you've got more different ways that you can achieve both high availability and site resilience, depending on where you place your witness server. So for instance, one thing you can do in 2013 that you can't do in 2010, or we strongly recommend that you don't do in 2010, is if you have a third location, such as a branch office or even a third data center, you can place your witness server in that third location, thereby giving you automatic failover for your DAG. Okay, again, that's something we just couldn't give you in Exchange 2010 because of the architecture. But you have that ability now in 2013, and that is a new configuration option that kind of makes the witness server placement a little more in-depth. So obviously in 2013, if you're going to have your DAG deployed in a single location, same rules apply. You're going to take the witness server and put it into the data center where you want the majority of votes to occur. If you're extending your data center, or excuse me, if you're extending your DAG across multiple data centers and you've only got two, then again, we would want you to put the witness server inside the data center where you want the majority of votes to be. If you are extending your DAG to more than two data centers, which you can do, again, we recommend that you pick one data center to host the majority of votes and construct your DAG with or without a witness server in that configuration. Now, the witness server is a required property for all DAGs, but we'll actually only use it if you end up with an even number of DAG members. If you have an odd number of DAG members, you'll have a witness server configured, but we won't use it because we'll be using the node majority quorum model and not the node and file share witness model at that point. And then, of course, multiple DAGs across multiple data centers follow the same guidelines as the single DAG across multiple data centers. But here again, you have the option of using other members from other DAGs as the witness for a separate unique DAG. Now, the third location. How many of you actually have three locations? 3, 4, 7 of you. Okay, 8. Okay, so the third location, if you are going to go the route of deploying your witness server in a third location, we pretty much just have one requirement for that, and that is the third location's networking infrastructure needs to be isolated from failures that can affect the other two locations. If you don't have that kind of network isolation, for instance, if you're in a hub and spoke where everything has to go through the hub, then you don't have that isolation and you won't be able to effectively get the site resilience that you want, because one network outage could take out everything, and you don't want that to happen. If you do have that isolation of networks, then a third data center does become a pretty good idea for a lot of customers. And again, it will give you, if you configure it properly, this automatic failover of your databases in response to a site-level outage. So you lose an entire data center, the DAG can lock the witness server in a third location and continue operating in your surviving data center. So it's a fantastically improved story over Exchange 2010. But whatever you use for your witness server, that has to be under the radar of the Exchange administrator, because if the witness server happens to be in use to maintain quorum, the last thing an Exchange admin wants to do is reboot one of the servers, which may lose quorum and cause everything to come down. So even though you don't necessarily need to use an Exchange server as the witness server, the Exchange admin still needs to be under the radar as well. Now, one other thing we're saying, and some of you may be able to do this, some of you may not be able to do this, if you have the ability to do so, we would recommend that the witness server in a third location be actually on a different continent or geographically distant from your DAG members. And that's simply because if you look at the map of the actual cables that go under the ocean, there are some regions, for instance, right where we are right now, where there's just one cable going in for the entire region. So if a submarine happens to go by and they cut that cable, all of New Zealand and much of Australia are completely disconnected. And so if you have a witness server that is geographically distant, that again is isolated from that type of failure again. Okay? It's something that we do in the service, something that we would recommend customers do, but we recognize not everybody can do that. All right. We had hoped at one time that we would be able to support Windows Azure, and specifically the IaaS, the Infrastructure as a Service functionality, where we could spin up a file server VM and a local directory server for authentication and have that be a third location for customers that only had 2 sites. Unfortunately, Azure itself does not support the underlying networking in order for us to be able to do that. So with Azure, it can do 2 types of VPN connections. One is a site-to-site, the other is a site-to-point. So the site-to-point would be analogous to individual clients, individual servers, making their own VPN connections into Azure. The site-to-site would be a VPN connection from the Azure site to your actual data center. Now, Azure only gives you 1 site-to-site, and we actually need 2, 1 for each data center. And so without that second site-to-site VPN connection, we can't use Azure. And don't even try to go the route of point-to-site, because point-to-site, again, isn't going to scale for you. But more importantly, there's no reconnection mechanism. So if that network drops between your individual servers and Azure, there won't be any reconnect, and everything will basically be offline at that point. Now, excuse me, the Azure team is well aware of our desire for this configuration. They have a formal feature request from the Exchange team inside their bug tracking list. Whether or not they do that is completely up to them. We can ask them for the feature, but it's up to them if they want to deliver it for us. I will say that Exchange is not the only entity that's asked them for this. Many customers have asked them separately for this as well. And we are tracking this extensively on our radar as well. So as soon as Azure does provide support for multiple site-to-site VPN connections, we will go through our testing and validation, and then again come out with support for that configuration. But until then, unfortunately, Azure is not supported for your witness servers. All right, let's talk about dynamic quorum next. How many of you have heard of dynamic quorum? Okay, just a few of you. So dynamic quorum is a Windows Server 2012 clustering feature. So it's in Windows Server 2012 and in 2012 R2 as well. And basically, it dynamically adjusts the number of votes that are needed to maintain quorum, provided that servers, after they go offline or they go down, provided that the system can maintain quorum after the loss of those servers. So basically, dynamic quorum is there to give you just a couple extra protection mechanisms in cases where we couldn't provide you protection in Exchange 2010. And that's what it comes down to. And this is an important distinction from all previous versions of the cluster, which had statically configured quorum requirements. So the votes remain the same, and they were based on whether or not the server was up or down. Now, this is enabled for all clusters by default. So when we test Exchange and when we run Exchange in the service and in production, we have dynamic quorum enabled for all of our servers. And that's the only configuration in which we test. And again, as I mentioned, it's the cluster dynamically managing the votes based on whether or not it can regain quorum after the loss of one or more servers. So the scenarios that it can protect you from are not really scenarios that you would want to rely on from a design principle of your DAGs, because there's no guarantee that dynamic quorum is going to take the vote away from the member that you want, or give the vote to a member that you want, and so forth. You don't really have a lot of control as to the decisions it's made, because a lot of them are random, simply based on the number of servers that are still up and running in that cluster at any given time. So let me go forward a little bit. Whoops. Yes, so dynamic quorum does not allow you to sustain multiple losses within a DAG or within a cluster that results in the loss of quorum and keep going. We have to be able to maintain quorum, or reestablish quorum, I should say, before dynamic quorum will actually do the adjustment and reduce the number of votes that's needed to maintain quorum. So that's important. You can't just have a whole bunch of failures and dynamic quorum will come and save you. It doesn't work that way. For dynamic quorum to make that adjustment, we have to regain quorum after one or more failures. So here's a brief example. We've got 2 data centers here. We've got 6 DAG members and a witness server, so we have a total of 7 votes that are needed to maintain quorum in this configuration. 6 for each of the DAG members, and then 1 for the witness server. And the witness server itself actually doesn't have its own vote, but it gives surviving DAG members an extra vote, and that's how we get the tie-breaking vote out of it. So let's say we lose the WAN link here. Okay, so now we've severed network connectivity between the 2 data centers. Can anybody tell me what's going to happen to the 3 servers over here in this data center? Are they going to stay up, or are they going to go down? They're going to go down, that's right, because we've lost quorum over in that data center. But we're able to maintain quorum here with these 4 votes that we have, because 4 is a majority of 7. And so because we're able to maintain quorum, we can go ahead and reduce the dynamic quorum count down from 7 now to 4. So let's say we lose another server. Not a problem. We can still maintain quorum because 3 is a majority of 4. And once we maintain quorum, we adjust the count again. So now we're down to a dynamic quorum of 3. And again, if we lose one more vote here, we're down to a dynamic quorum of 2. And that's basically this last man standing here that has locked the witness server, and it's now up and running and keeping the solution up and running. Now, of course, in order for this to be successful in your deployment, this one server typically would have to be sized to carry the entire load of the 5 servers that are down. You're probably not going to configure your servers to do that. So even though dynamic quorum may be able to keep a server up and running, that doesn't necessarily mean that all of your databases are going to mount, or that you'll be able to service the increased user workload that will now be placed on that server as a result of all these other servers being down as well. Now, one other thing to mention is, let's just, excuse me. You can't tell, I'm a little sick. Let's say we lose the witness server, and we've got just these 2 exchange servers up and running here. What dynamic quorum will do is it will actually reduce the count down to 1. But you have no control over which one of these servers gets the vote and which one gets taken away. And so what that means is you need to go in and use the cluster tools to figure out which one has the vote, because if you need to reboot one of those servers, you don't want to reboot the one with the vote, because it'll take out the one without the vote as well. So you need to be aware of where that vote is going. And again, you have no control. The cluster will randomly choose one node to have the vote and randomly choose one node to not have the vote as well. So how do you figure out? You can use the get cluster node commandlet to do that. And what you're looking at is this dynamic weight of value. If it has a value of 1, then that server has a vote. If it has a value of 0, then the server does not have a vote. Also, right next to the dynamic weight is this other property called node weight, and that's also a 1 or a 0. This is where the administrator can manually take votes away from a cluster if they needed to for whatever reason. Typically, there's no reason to do that for DAG members, but this is how you can tell by looking at the node weight property if an admin has actually taken a vote away. So you can also use the validate cluster quorum test inside the cluster GUI to check this stuff as well. Now, dynamic quorum does not change the quorum requirements for DAG. Okay, so we still need quorum in order to mount databases, and the fact that the cluster is changing things dynamically now really doesn't change anything from a DAG perspective. Dynamic quorum, as I mentioned, works with DAGs. All our internal testing is done with dynamic quorum enabled. All of Exchange Online and Office 365 are running with dynamic quorum enabled. But Exchange is not dynamic quorum aware. So it has no idea that votes are being taken away or that the requirements for quorum are being adjusted out from under it. All Exchange knows is whether or not the cluster tells it it has quorum. And if the cluster tells it it has quorum, Exchange will keep running. If the cluster tells it it doesn't have quorum, Exchange will start to terminate the replication services, and then the cluster service will also terminate on that server as well. So our guidance on dynamic quorum, the cluster team has their own guidance, and the Exchange team has our own guidance as well. The cluster team says basically, keep it on. You will get potentially availability in failure scenarios where you weren't getting it before. The Exchange team guidance is largely the same. Leave it on for the majority of DAG members. We don't have any guidance as to when you might want to turn it off. But as I mentioned, don't factor it into your availability plans because of the random and dynamic nature of it, no pun intended, you won't necessarily be able to have that control over where the votes go. And as a result of that, you really just want to plan both from a capacity standpoint and from a resilience standpoint as if dynamic quorum did not exist. Okay? So leave it on. Maybe it will provide you some benefits, but don't plan for it or rely on it in your designs. All right, let's talk a little bit about DAG member maintenance now. And I wanted to talk about this because the way in which you put a DAG member into what we call maintenance mode has changed significantly since Exchange 2010. In 2010, we included this script. It was called start DAG server maintenance.ps1. And basically, you would run that script, and it would make a whole bunch of changes to the DAG member. It would, for example, pause the cluster node, so that it would prevent that server from inheriting the primary active manager role. If that server was already the primary active manager, it would move that role to another server. It would also move all of the active databases off that server, basically do a server failover, if you will. It would also block databases from becoming active on that server, and basically do everything to quiesce all DAG and cluster functions so that you could do things like install updates or perform hardware maintenance or do other tasks. Once you were done with those types of tasks, then you would run the stop DAG server maintenance script, and that would basically undo most of the things that the DAG server maintenance script would do. It would not reset any block settings that you have. We'll actually clear them all after running that script, so you would need to go in and re-invoke any database mounting blocks that you had before. But otherwise, it will simply undo all the other stuff that the start script would do. Well, in 2013, the guidance gets a little bit more complicated, in part due to the fact that things like Hub and CAS and are now running on Mailbox, but also because of managed availability as well. So let me walk you through some of these commands that we have. So the set server component state is one of the commandlets that you'll use to control the behavior of managed availability components. So for example, the first line, we're going to be running set server component state, passing in the server name. In this case, the component name is hub transport, and we're going to take transport, all the queues basically, and put it into a draining state. And then the requester can be a variety of things. When you're doing these things manually, you're going to put the requester being maintenance on that. And so what this will do is it will take all of the queues in the hub transport, and it will basically pause them. So we'll continue to process messages that are in the queues, and we'll basically drain the queues, but we won't allow any new messages to come in. Similarly, the next line with this set server component state, and this time the component is the call router, that's something that you would do on CAS, and basically that does the same thing. It drains those calls so that any calls in progress can continue, but we won't allow any new calls to be created on that server. We're basically trying to quiesce all user activity on there. Now, we've also introduced back in CU1 this redirect message commandlet, and what that does is it lets you drain your hub transport queues even faster, because you can literally take the messages and redirect them to some other transport server in your organization. So the queue will be doing both. It'll be processing messages, but it'll also be sending messages over to another server for delivery as well. And that will drain your queue much faster than just the draining component that we did first. Then you'll suspend the cluster node. Again, that's equivalent to pausing it. That allows the cluster node to still participate in things like quorum decisions, but it doesn't allow it to inherit the primary active manager role or become the owner of the default cluster core resources. And that's important because you don't want it to have either of those things if you're about to reboot that server. Then you would run set mailbox server and use the database copy activation disabled and move now parameter. And that's going to go ahead and block activation on that server and take all of the active databases on that server and move them to one or more servers in your DAG. Then you would run the database copy auto activation policy and set that to block, to explicitly block all activation from occurring on that server. And then the last thing that you would do is another set server component state, only this component is called server-wide offline. The server-wide offline component is kind of a catch-all bucket for every single managed availability responder that exists on the system. And remember, it's the responders that are responsible for taking recovery actions. So we're turning off the responders because the responders, their recovery actions could come and undo some of the things that you're doing. For instance, if you leave them on and you turn off a critical service, managed availability is going to come and turn that service back on. So you don't want managed availability to undo things you're trying to do as part of your maintenance. So you need to turn the responder components off so that they don't take corrective action and mess up your maintenance plans. Once you're done with all those, I do like to take this extra step of verifying that every commandlet that I just run completed successfully. And I do also like to run get queue perhaps several times so that I can make sure that the queue is actually drained and empty before I go ahead and turn the server off or do some form of maintenance on it. Goodness, excuse me. All right, when you're ready to come out of maintenance, you're basically, you're basically undoing the commandlets that you ran to go into maintenance. So for example, the server-wide offline goes from a state of inactive to active. The call router goes to an active state. The cluster node gets resumed. You set the database copy activation disabled to move now to false. You can unrestrict, or if you need to block, keep these blocked for whatever reason, you can do that. And then you allow transport to start receiving messages again. Then after that, once again, I do like to verify that everything is operational and set back the way it is, so I run these verification steps at all. And here again, I also do get queue just to make sure that the queue is starting to receive messages as well and to do its thing. In case you're at all curious, these are exactly the same steps that we do to put servers into maintenance mode in Office 365. So you are basically doing the same thing we do when you're doing maintenance on your servers. All right. So with that, I wanted to leave time for questions, and it looks like we've got about 10 minutes for them. And when we talk about questions, that can be anything that we've covered today. It could be anything that we covered in the prior HA session, or really anything about HA and site resilience that you want to know, starting with this gentleman.
What's the current position if you've got a two-node DAG, one-node data center, a mailbox in each data center for those users? So you're doing it across everything, and we're trying to back up one because that didn't be supported with Windows server backup.
Sure. So the question is, what if you have a two-node DAG and it's stretched across data centers, and you're asking about backing them up? Yeah. So you can back up either server. You can back up active copies or passive copies. We do include the plugin for Windows Server Backup, just like we did with Exchange 2010. So you should be able to back up the copies using that. We also do support other VSS backup applications, so you could use something like System Center Data Protection Manager, or basically any other third-party VSS backup application that you might have in your environment.
Should you back up the primary or the active?
That is your choice. So the question is, should we back up the active copy or the passive? You choose. We support backing up both. Obviously, if you're backing up the passive, you don't have to run into any user contention. But the VSS framework really enforces a very quick backup operation. In fact, we have to actually do the snap within 10 seconds or less. Otherwise, it's not considered a valid backup. So even if you are backing up the active copy, that shouldn't impact user activity at all, unless you're already in a substantially resource-constrained environment. Now, the one thing I will say about your topology is you really only have site resilience. You don't have in-data center high availability, because if you lose one of the servers, everybody's going over to the other site. You don't have redundancy in that data center. That might be intentional on your part, and that is a supported configuration. But typically with Exchange, we like to see both in data center HA and site resilience. Yes, sir?
If you end up in a situation where, like this guy over here, mailbox with 2 sites, you lose one of the sites, and that might be a hardware failure, and that was your primary site which had your witness or whatever. Is it supported to then bring up the single copy you've got of your mailbox databases on the third member that has no quorum? Is that something that's
So at that point, when you lose the majority of votes, you've lost quorum and the entire solution comes down. In order to modify that cluster, modify that deployment, you actually have to regain quorum and bring it back up. So what you would do is a process that we call a data center switchover, which would involve you running a couple commandlets. One would be stop database availability group. That would go ahead and take the server that's failed and mark it as down. Then you would run restore database availability group, and that would effectively evict the failed server from the underlying cluster, thereby reducing the requirements for quorum. And then it would perform a force quorum operation on your surviving server, which would bring it up, in this case, in a single server deployment. Exactly. Although in your case, when you run restore DAG, you will need to specify what we call an alternate witness server. And in case you're not familiar with that, the alternate witness server is simply the name of the witness server, or simply how we refer to the witness server that you use when you're recovering service in an alternate data center. So the alternate witness server, it doesn't provide redundancy for the witness server. We don't fail over between the two. It's just a different name to indicate that you're using a new witness server in your alternate data center. So restore DAG, you can pass the alternate witness server parameter with that, and that's how you would configure it and bring the solution up and running. So you would actually have 2 votes at that point. And then if you needed to, because you've got quorum, you could go ahead and add additional servers if you want to. The thing to be aware of is, though, that will extremely complicate the switch back when you go to restore service to the failed server, because the failed server won't know anything about the addition of new servers, and that means you may end up using some cluster tasks and not just the native Exchange tasks. Yes, sir?
Just in regard to witness placement at a third site, if you've got a site that has databases mounted, and that site is connected to the rest of the LAN, so all those are going to go down.
Well, they'll fail over. Yeah, once they lose connectivity, as long as you can maintain quorum, those databases will fail over and become active on one or more of the servers that still has quorum. Yes?
I've had a scenario where I changed the certificate on a server, and the managed availability with the UM4 out sort of out of action. The only way to get it back was to manually set that component, certain component to active again using the Alt API.
Mm-hmm.
Is the managed availability supposed to automatically detect that there's a working certificate and automatically put that certain component active, or is it always a manual?
So when you're using the tasks to manipulate it, it's the admins explicitly saying that I want to stop managed availability from doing things. So once you've done that, then managed availability won't be able to take any corrective action. It still does the evaluation, so the probes still fire, the monitors still evaluate the results from the probes, but the responders don't get invoked because you've basically taken the server-wide offline and made it inactive at that point.
So I didn't manually set the anchor. I just upload the certificate and by default the old APIs of the managed availability make that server component be called out the in-anchor. And there was no way it manually made it active again. I can manually go and set that server component active.
Oh, that's interesting. No, that doesn't sound like the normal or expected behavior. If you can actually, if you want to send that to me in email, I can do some research for you and find out what might have gotten you into that situation. Yes, sir.
So we're a 2010 environment at the moment, we're staying in 2010. We are keen to have some archiving done. Would you recommend archiving in the 2010 environment or having a new archive mailbox database in the 2013 environment?
How are you doing archive now, just with the built-in archive mailbox? Okay, but you're using the archive mailboxes in 2010?
No, we don't have any archive mailboxes.
Okay, how are you doing the archiving in 2010 then? How are you doing the archiving in 2010?
We don't.
You're not, okay. Sure. So you can do that if you introduce 2013 into a 2010 environment. You can have the primary mailbox be on 2010 and an archive be on 2013. You probably get a better experience if they were both on 2013, but we don't require that. There is one other feature that we have. It's actually on the Outlook side that may drive you to not using archive mailboxes at all, and that's the slider control that Outlook 2013 has. And the slider control is based on a date range, and it allows you to control through the Outlook client how much data gets synced down to the OST file. Now that's typically why most customers deploy archive mailboxes, to limit the amount of data that gets synced down to the OST file. Only the primary mailbox goes to your OST file. The archive does not. It's always an online archive. So you've got choices now. You could deploy archive mailboxes on either platform, or you could deploy Outlook 2013 and just give your users a large primary mailbox, but use Outlook to control how much goes down to the OST file. Yes, sir?
So just following on from that question, with the slider that's now in 2013, does that improve the performance of Outlook itself if you've got a large mailbox?
Well, it really depends on where the OST lives. So if you're on an old laptop, for instance, that has a 5400 RPM drive and there's other heavily used disk activity on there, then yeah, you'll see improved performance because it's a smaller data set on disk that we have to go through. But if you have a new desktop, or if you've got a new laptop with SSD, something like that, then you may or may not notice any changes in performance. You'll just notice that the size of the OST file is larger or smaller depending on your settings.
So the performance of Outlook is actually related to the hardware you're on. As much
Absolutely.
as the items.
Absolutely. In particular, the disk. Yeah, absolutely. Yes, sir?
When does the witness server actually get queried? Is it only in times of where quorum is to be achieved, or is it a real-time monitor that says, oh, if you turn this witness server off and you've got two Exchange servers, suddenly we're going into quorum of one? Does that then affect the two, presumably functional?
Sure, great. So the witness server, it's used two ways. First, it's heartbeated by the cluster. The cluster has a representation of the witness server called the file share witness resource that lives inside the cluster core group. Excuse me. Goodness, jeez. If that heartbeat fails, that resource will go into a failed state, and the cluster will fail over those resources to another node. And we'll try to bring them up. If it can't, then that resource will remain in a failed state.
The resource being the witness server?
The file share witness resource. It's the only other cluster resource besides the network name and IP address that you'll see.
So would it try and fail it over to the second Exchange server?
No, it's trying to fail over the core resources itself to another cluster node. So that's actually not an Exchange function, that's a cluster function. The way it will come into play from a quorum perspective is when you start losing your DAG members. When they go down, once you're at a point where that witness server is needed to maintain quorum, because you're one vote away from losing quorum, that's when one of the nodes, typically whichever node owns those resources, will also be the primary active manager. It will put a lock on that witness server file. And when it does that, then it gets the extra vote and maintains quorum it that way. That is the only way, the only ways in which the witness server is used. It's heartbeated by the cluster, and then it's locked by the primary active manager when it's needed for quorum.
What I'm trying to get at is are we introducing this witness server in a way that actually now means we need to put resilience in the witness server?
No, the witness server is not a single point of failure, and it doesn't need to be made redundant. In fact, we don't recommend that you make it redundant because that just adds complexity. It's, again, a very lightly used file share that will only be really coming into play when it's needed for quorum. Yes, sir?
So if you've got a hybrid environment with 365, does that get any say in the voting?
No. DAG members can be on premises only. You can't have a DAG or a witness server that lives in the cloud.
So you're going to use 365 as your witness?
Well, if you want to use Office 365, you use it as your entire infrastructure. And actually, in that case, then you get high availability and site resilience with zero admin effort on your part. Lots of admin effort on our part. Yes. In the back.
Just because I'm a little bit lazy, is there any thought of putting staff maintenance that's putting into the management console as opposed to?
Right, so the start DAG server maintenance script is actually from 2010, so you won't use it in 2013 anymore. Yeah, so the other scripts, no, that's not going to make it ever in the console. About the best we might do is turn it into a single PowerShell script for you, so you can just run it once. But that's nothing that's ever going to be into the console, because typically inside the Exchange Admin Center, it's only going to be things that will be more commonly done. Not that common. Not that common. Yes?
If you put the mailbox on hold for people visits, and but at the same time that same mailbox is enabled for archiving, and say if the user deletes an email, and it's kept in its area down the middle in the primary mailbox, and after 30 days or whatever your intention is to move to the archiving, what would happen to that in the first? Does it move to the actual archive mailbox, or does it stay in the primary mailbox?
Sure, so that is completely not related to HA, but I'll answer it anyway. So both will happen. Because you've got the archiving set up, the message will make its way in there. And because you've got the hold set up, it will also be in the hidden in the store in that dumpster area as well.
Yeah, but is that on the archive mailbox or on the primary?
No, it'll be on the primary mailbox.
Even, okay. So the email is deleted before it's been archived?
Correct.
Yeah, so it would never make it to the dumpster area in the archive mailbox?
Correct. All right, yes, sir. We do need time. Oh, I'm over, so this will be the last question. Hyper-V Replica, fantastic question. Hyper-V Replica is a great feature for applications that don't have their own HA story. Exchange does, and so we actually don't support Hyper-V Replica for Exchange. We don't really see any benefit or reason to do that, and so you can use it for your other apps, but you just won't be able to use it for Exchange. All right, thank you very much. If you have any other questions, feel free to send them to me, and enjoy the rest of TechEd.